to display this, to make a picture of these distributions, I can use pie charts. I'm not a big, as you know, a big fan of pie charts, but we can. And what this does, right? These are conditional distributions of those two groups, the alive. So I'm looking at sort of all the passengers that are alive, and it's about a quarter, a quarter, a quarter. Second class is a little less. Then I look at all the bodies, and I put them in their respective class categories, and you can see that the crew was huge, right? The dead bodies of the crew. There were many, many, many crew that were dead, and many, many third class passengers that were dead. This actually tells me a lot about how like, for example, the first class passengers were fared on the Titanic. We can also look at this in terms of a bar chart. So this bar chart actually shows the percent in first class, right, that were non-survivors that died. Okay, so 30%, almost 40% were not of the first class passengers actually perished, where 60% of the second class passengers perished. But that's not anything compared to the third in crew, where it was almost 3/4 of the third class passengers, and definitely the 3/4 of the crew all perished. So we can look at the pie chart, bar chart here, the bar graph. So which one is best? The table that we started with, the pie chart, or the bar graph? Well, it depends on what you want to do. I actually really like the bar graph, because what this allows me to do is quickly focus in on the tallest bars, right? These are the worst bars, or the shortest bar, right? And that's the best bar to be in, right? The first class passengers, not a high mortality. Okay. Now that we have this notion of contingency table and marginal distribution and conditional distribution, we want to add one thing to this and look at independence. And what this means is, when I have two variables, are they in some way connected? So as I started the whole unit. So independence would mean that if I looked at the distribution of one variable, it's the same for every category of another variable. I'll give you an example of this in a second. Okay, so we would talk about independence if we saw the same distribution repeated again and again and again for the first class passengers, second class passengers, third class passengers, and crew. I would say, oh, look, the class is independent of your survival. That's not what I saw. I actually saw a different distribution, right, for the first class passengers, for the second class passengers, so forth. And so these were not independent. We don't use the word dependent usually in statistics. Rather, we say, oh, those two variables were associated. There was an association between the class you were in and your survival. Pretty clear. And so this is where we get back to this word association. So let's give another example. So I would definitely, by the way, I would definitely say that the variables independent, the class on the Titanic and your survival were associated. Okay. Let's try independence. Let's try another example. So a company was interested in, surveying people who were going to go watch the Super Bowl, and they were interested in the differences between men and women, if there were any. So they actually surveyed a bunch of people, and they asked, are you going to watch the Super Bowl or not? And if you are going to watch the Super Bowl, are you going to watch it for the game or for the commercials? And they collected the responses, right? So, and broke it down by sex. So we see the males here, and by the way, what's 492? Oh, that means they actually asked 492 men, and the 516 means they asked 516 women. Okay, and there were 1,008 people that they asked. Don't want to spend too much time on this, but this is the marginal distribution of the response. 479 people said that they were watching the game 237 said they were going to watch the commercials, and 292 said they weren't even going to watch the Super Bowl. And these numbers right here in this margin don't break down by sex, right? This is 479, which some were men and some were women. Okay. Now, these numbers I need to look at a little bit more. So what I'm going to do is I'm going to look at the conditional distribution of the response for the men. All right. I'm going to say, okay, let's look at all these men, 492. What percentage of the men were going to watch for the game, what percentage were watching for the commercials, and what percentage of men were not going to watch of those 492, and do the same thing for the women. And if your sex and your response are independent, then that distribution, percentage of men who watch for the game, for the commercials, or won't watch, and this distribution, game, commercials, and won't watch for the women, would be the same. But are they? Well, let's make a picture, right? So here's a bar graph where I've now got two panels. I've got actually two bar graphs, right? Here's the female bar graph and the male bar graph. This is the percentage of women who said, oh, I'm going to watch for the commercials. Here is the percentage of women, it's about 40%, who said they're going to watch the game, and here's the percentage of women, a little bit over 30%, who said I'm not going to watch. And then in the men, right, I've got the men who said, oh, I'm going to watch for the commercials. It was about 15%. The men who said they're going to watch the game is 55%. And the percentage of men that were going to watch, who are not going to watch the Super Bowl, is about 30%, a little less. Okay. What did we notice? The first thing we should say, well, does there seem to be an association between your sex and your response to this questionnaire? And the answer is absolutely. There seems to be an association. The two distributions, right, the two pictures, do not look at all alike. The distributions are different. Okay, so that means there is an association. To break that down a little bit more, you look at the women and see the commercial and game percentages. It's about 30%, 30%, 30%, and 40%, right? Not a very big difference between the women that, the percentage of women that said, oh, I'm going to watch for the commercials and I'm going to watch for the game. Whereas on the men's side, it was a huge difference, right? Only 15% of men said they were going to watch the game, watch the Super Bowl for the commercials, and over 50% said they were going to watch the Super Bowl for the game. So the difference between the men and the women is really located in there. It's actually kind of interesting, I think, that the percentage of women and the percentage of men who won't watch the Super Bowl are about the same. If they're not that drastically different. So this difference, what they're saying right here, is the difference is small here but big here for the males. So there's definitely an association because those two distributions are not the same. The conditional distribution of your response if you're a woman and the conditional distribution of this response given you're a man are very different. And so, not surprisingly, there is an association between these two variables. Now what we want to do is move on to a quantitative variable, because you notice everything we've done up to now has been two categorical variables. And so this is data, I'm taking it from some similar data from the book where I'm looking at the wind speeds in this Hopkins forest. But one of the difference between my presentation and the book is that I'm actually looking at the maximum wind. So each day of the year, for a full year, the meteorologist reported what was the fastest wind for that day. Okay, and I want to look at the distribution of that. And you can see that, there weren't many days that were very calm, right? This is where 0 was the strongest wind, and there were quite a few days that were up in the 30 miles per hour range, right, to low high 20s or low 30s. And I look at the distribution and I say, okay, describe this with unimodal, slightly right skewed. The box plot down here, right, the median was around 10 miles an hour. There were actually several outliers, that were picked up that were kind of unusually fast winds that day, maximum winds. And so I've got interesting things to look at there. And then I also do my data table. So all the stuff we've been doing now comes to play. They've got my 5-number summary, my mean and standard deviation. So it, and in the number for 365 days, so I have 365 observations and none of them missing, right? No missing data. So that allows me to get another handle on this data. Notice though, I'm only doing one variable. I'm just doing the max wind, the maximum wind speed, looking at the distribution of that. Just to go, typically, no. Oh, by the way, I have to change these numbers. The typical speed was not less than 1 miles per hour. It was less than 10. It looks like around 10 or 15, right? That was typically, you never got faster winds than that. There were a few high wind days up there where we got up to be more than 20 miles per hour at least at some point during the day, and there was one particularly windy day with 6 miles per hour is not. It was up there at in fact, what was it? It was, we can look at the 5-number summary, right? The maximum 32 miles per hour. It got up to 32 miles per hour that day. That was the strongest wind they saw that year. The IQR is not 1.8 miles per hour because what is it? Well, it goes from Q1 to Q3. So that's looking around 7, 7.3 or so miles per hour. So, it gives me, the maximum wind. We're within 7 miles per hour of each other. So not a huge range. But now I start to think, well, wait, the seasons are different, right? In a forest, you've got the summer months and maybe the spring months, but let's make things easy on ourselves. Let's just talk about the summer versus the winter. Is there a difference between the wind in the summertime and the wind in the wintertime? So what I'm going to do in this case is actually do 2 histograms. This is the same data where I've taken those 365, but I've broken it down where I've plotted about half of them over here. These are the numbers that I had before, but plotted just the summer months, a histogram of the summer months. And then I get the histogram of the winter months as well, right? Those 6 months of the winter. And what we see, if you look at these 2 graphs, is that the histograms look different. This is unimodal, summer months are unimodal and kind of right skewed, where the winter months, there's this sort of almost uniform block in the middle. I mean, there might be a little bit of right skew, but the uniform block. More than that, look at where the main mode is. In the summertime, it looks like it's pretty typically less than 10 miles per hour. But in the wintertime, you have some things that are less than 10, but there are some things that are more, and in fact, quite a bit more, right? So 10 and 15 and 16 and 17 out here. So this mode kind of stretches out that way. So I see a couple things going on there. Okay. So looking at that, we can immediately say that the season, winter or summer, is associated with the wind, or vice versa, that the wind is associated with the season of the year we're in. Okay, so that gives us some something to work with. The wind isn't consistent all year. There is a definite windy season, right? Here's the things again. If I look at this now, I'll do the same kind of analysis I did before, but look at the summer months by themselves and the winter months by itself. So typically a summer wind is less than 12 miles per hour. Very rarely gets above that. There are a few days though, okay? Whereas a winter, it's usually under 20 miles per hour, but almost always more than 6. And so it has there's that sort of typical winter wind is a little speedier. it is also more spread out. If you look at, think about the standard deviation and the interquartile range, I've got a lot of spread here between the slow winds and the fast winds. Where in the summer it's pretty consistent. It's not quite as spread out. Okay, it's not. Just to conclude, and it's not very windy in the summer, but winter does have some pretty windy days. Finally, what I want to do is look at the favorite statistics of these two groups. And by the way, again, doing this in R is actually pretty easy. I'll show you how to do this in another lecture, getting a table like this. But we see the same tail, right? Look at the measures of center, medians. So from the summer to the winter, the median summer maximum wind is 88.6, wherein the median in the winter is 12.49. So a little bit faster winds in the summer. Same thing with the mean, right? The means are higher. The mean max wind is in the winter is higher. The interquartile range. Look, I go from 6.26 to 11.91, so about 5.5 in the summer is the interquartile range, and in the winter time it's 9.05 to 16.71, so that's 7. So again, it's more spread out in the winter. By the way, the standard deviations tell the tale, but a little bit differently. And in fact, obviously with the kind of histograms I have here, with the skew, maybe some outliers, probably want to use the median and interquartile range to make my comparisons. So it comes down to, look, the winter is windier, substantially windier than the summer, and both the standard deviation and the IQR show that there's a bigger variation in the winds during the winter months than there is during the summer. Summer's more consistent.